Okay, students, today we're going to talk about how to predict products of reactions. So here I have some chemical reactions on the board behind me, and we're going to figure out how to predict what the products of those will be. So for example, we have aluminum chloride reacting with barium sulfide, and we want to know what's going to happen. Or how about if we have sodium chloride reacting with oxygen? What are we going to get? Or what if we have C4H10, that's a hydrocarbon. They have a weird naming system, but this one is butane. So if you have butane reacting with oxygen, can we predict what we'll get from that? So when we're done with this video, you should be able to predict the products of each of these types of reactions. Okay, to continue on with our chemical reactions discussion, I want to review briefly the 6 types of chemical reactions that we learned about. So we learned about synthesis reactions where 2 individual elements bond together and become a compound. In a synthesis reaction, you'll notice that there's a plus sign on the left side and no plus sign on the right side. Decomposition is the opposite of that. So you have a compound that breaks into its 2 elements. So you're going to see a plus sign on the right side, but not on the left side. Single replacement is where you have a compound, 2 elements bonded together, and a single element. And the single element is going to replace one of the 2 elements in the compound and bond with the other one and kick the one that was bonded out. Double replacement is almost the same, but it contains 2 compounds where the 2 compounds switch partners. So these 2 are partners, and now these 2 are partners, and these 2 are partners, or something like that. Combustion is a special type of reaction that kind of looks like a single replacement reaction. It's really not, but it kind of looks like it. It's where you have a hydrocarbon, which is a carbon-hydrogen compound. Could be any formula that has carbon and hydrogen in it. And that reacts with oxygen, and every single time it forms 2 products. Those are carbon dioxide and water, and those are the only 2 products that you should get in a combustion reaction. And the last one is acid-base, which is a special version of a double replacement reaction. In an acid-base reaction, you have an acid, which is something in general that starts with an H, and you have a base, which is something that ends with a hydroxide ion. So if you see on the left side an acid and a base, it's probably an acid-base reaction. So I'm going to skip ahead a little bit here, and we're going to talk about how to predict products. The most important thing to think about or to know about when you're predicting products, here we go, is how to read the periodic table for charge. Now, we've done this lots and lots and lots of times. You should be very good at this point. But just in case there's anybody who's confused about how this works, I'm going to review real quick. So the first column on the periodic table, that is the family that hydrogen is in. That is all the alkali metals plus hydrogen, which is not technically a metal. Those guys are all going to form +1 ions the vast majority of the time. So that's what we're going to assume they're going to do. These elements are going to form +2 ions. The transition metals get a little weird, so we skip over them. Boron's family is going to form +3 ions. Let's go back. That's +1, +2, +3. Carbon's family is unique because those atoms can either gain 4 electrons or lose 4 electrons. So they could either have a -4 charge or a +4 charge, depending on what they're bonding with. They typically will bond with things with the opposite type of charge. Nitrogen's family will have a -3 charge. Oxygen's family will have a -2 charge. Fluorine's family will have a -1 charge. Let's review those one more time. +1, +2, +3, +4 or -4, -3, -2, -1. You will be expected to know that and be able to look elements on the periodic table up and figure out what charge they would have. And you were expected to know that in the last unit as well, but some of you, I think, are still struggling with this concept, so thought we had a review. So here we go. We're going to predict products of a reaction. The first thing you have to think about is what type of reaction it is. So the first thing you want to do is look at the left side and say, okay, what reaction is this? And if you have a reaction that has only 2 elements in it, the only thing those atoms could do is bond together. they can't break any bonds because they don't have any bonds to break. So sodium and sulfur could bond together. And if they bonded together, do I have the answer in here? Oops, there we go. You have to look up the charges for each of these. So here's sodium. Here's sodium. Come on, sodium. Sodium is +1, sulfur is -2. And when you put those together, you're going to get Na2S because you need 2 sodiums, 2 + 1 sodiums to bond with a -2 sulfur. Let's review how we know that's +1. Here's sodium here, and it's in the +1 column. Here's sulfur here, and it's in the -2 column. So here's another example. All right, where were we here? So in this situation, we're looking at a decomposition reaction. If you have only one compound on the left and it's not reacting with anything else, it can only decompose. Decomposition tends to happen when you heat a compound up to a high temperature or run electricity through it or something like that. Most compounds don't decompose on their own, but sometimes they do over long periods of time or whatever. So in this case, our compound, Kf, is going to split into K and F. That's pretty simple, right? But there's a little something you need to remember. So we got our K and our plus F, but the thing you have to remember is that you have to ask yourself when you're looking at an element, when you're writing down an element, is it a diatomic element or not? So potassium does not end in gen or ene, so it's not diatomic. Fluorine does end in gen or ene, so it is a diatomic element. So you have to write it K plus F2 for our products. And this is, as you'll notice, an unbalanced chemical reaction. So oftentimes you'd see a question like this that says, predict the products and then balance the equation. So to do that, we would fix the fluorine by putting a 2 here and fix the potassium by putting a 2 here. This one is combustion. Anytime you have a hydrocarbon reacting with oxygen, it's going to be a combustion reaction. Hydrocarbons are carbon, some number, hydrogen, some number. That's their formula. There are thousands, maybe millions of them. There are many, many different ones, but they all do the same reaction every time they're around oxygen, which is in the air, so it's pretty often. And that reaction is that they produce carbon dioxide and water. So here's our CO2 plus H2O. And this is an unbalanced reaction. If you want to pause and balance it, you can do that, but I'm not going to at this point. We'll review that some more as we go along later on. If you choose to write H2O plus CO2 instead of CO2 plus H2O, that's totally fine. It means the exact same thing. It's not a problem. So here we have an acid and a base reaction, and we want to know what the products are going to be here. We know this H2S is an acid because it starts with H. This is hydrosulfuric acid. And this is a base. We know that because it ends in OH. So this is calcium hydroxide. So they're going to react in such a way that the H from the acid gets together with the OH from the base and makes water, and the other two ions get together. So the other two ions, we have to think about what they're going to make. So we've got calcium and sulfur. And here's calcium. Oops, I highlighted oxygen. I meant to highlight sulfur, but it's okay, same charge. So calcium has a +2 charge. Sulfur has a -2 charge. So when they bond together, it takes one of each to make that compound neutral, which is what we're trying to do. So we're going to get calcium sulfide, which is CaS, one of each. And we're going to get water. And that's the rest of our equation. And again, it's an unbalanced reaction, so we would have to balance it in most cases. Single replacement reactions get a little bit tricky, and there's a series of steps that you should probably pause and write down.
Olivia Williams.
Sorry for the disruption there. It's at the end of the school day, so we've got kids coming and going and announcements going on occasionally. So anyway, single replacement, like I said, is tricky. You should probably write down these steps. So in a single replacement reaction, first thing you want to do is break the reactants down into their ions, and then you're going to make a new compound from those ions. And you're always going to write the cation first in your new compound, and then the anion that it bonds with. And the other element's going to be kicked out by itself. It's going to be alone. So you have to ask yourself, is that other element diatomic? And if it's diatomic, you got to put your subscript too. So here we have NaCl and F2, and we're going to have at the end of it an element and a compound, or maybe we'll put the compound here and the element here. It doesn't really matter. But we got to see what that's going to look like. So we have to write out the ions. So sodium is really an Na+1 ion, and chlorine is Cl-1. Again, how do we get those charge numbers? On the periodic table. Fluorine right now doesn't have a charge, but it could have a charge if, and if it did have a charge, it would have a -1 charge because it's a halogen, and those guys are always -1 in that second to last column on the periodic table. So now we had these two, sodium and chloride, bonded together. Now we're going to switch it up where something is bonded with fluoride, and fluoride is negative. It's only going to want to bond with sodium. So on our reactants, on our product side, we're going to put sodium with its +1 charge and fluorine with its -1 charge. Those kind of overlapped. And then chlorine is going to be the element by itself. Now, of course, this is not how you're going to write your compounds. Cl is going to be written Cl2, and Na+1 and F-1 is going to be written NaF. So NaCl plus F2 yields NaF plus Cl2. And this is an unbalanced equation, so if you want to pause and balance it, you are welcome to do that. Here's another example of a single replacement reaction. These are a little bit tricky, like I said, so I want to do a few examples. So to split CaF2 into its ions, we know that it's Ca+2 because we can look it up on the periodic table. Fluorine is F-1. Chlorine is Cl-1. So we've got fluorine and chlorine again. And here we have chlorine that wants to bond with something. And so it's going to kick fluorine out and bond with calcium. Why will calcium and chlorine bond and not fluorine and chlorine? Because the opposite charges are going to attract. So calcium and chlorine are going to bond together. We always write the positive ion first, the cation first. So those two will be together, and fluorine will be alone. So this will make CaCl2. We need 2 chlorines to cancel out the calcium. And fluorine, of course, is going to be written F2 because it's a gen or an ene. Why did it change those arrows into A's with hats? Okay, so this one we have, okay, I'm going to have to fix this one. Okay, this thing's being really difficult here, so we'll see if we can get it to cooperate this way. All right, so we have AlCl3 plus rubidium, and aluminum chloride is going to be made of 2 ions, the aluminum +3 ion. Because of its location on the periodic table, we know it's +3. And the chloride ion, which is Cl-1. And rubidium is a +1 ion. So in this case, the rubidium is going to bond with something, and it's going to bond with the negative ion, the chloride ion. So aluminum is going to go by itself, and the rubidium goes next because it's the positive ion, and chlorine bonds with it. Now, if we wrote RbCl here and Al over here, that's totally fine. And so our reaction is going to end up saying Al. Now this is aluminum, which it does not end in gen or ene, so it doesn't have a subscript 2. And there's no subscripts in this one because a +1 and a -1 cancels out. And again, this is an unbalanced reaction, but this is something that you could pause and balance if you'd like to. Double replacement is kind of like single replacement. You're going to split the molecules into their ions. It says molecule, but there's more than one. You're going to make new compounds with opposite charged ions together, and you're always going to write the cation first. So here we have Na2O, sodium oxide, Ca3P2, this is calcium phosphide. And we're going to write the ions, Na+1, O-2, Ca+2, and P-3. Where did I get all those numbers? From the periodic table. And then I'm going to pick a cation to put first, and then the other anion is going to go with it. So I'm going to start with sodium as my cation. Sodium was bonded to oxygen. It's now going to be bonded to phosphorus. And then I'm going to put the next cation. So I'm not going to put the oxygen next, even though it's sort of next in line. Calcium is going to go next because it's a cation. And then oxide is going to go with it. And when we put these together, it takes 3 sodiums to cancel out a phosphorus, and 1 calcium cancels out 1 oxygen, plus 2 minus 2. So our equation should look like this, Na3P and CaO. And again, it's unbalanced, but we could fix that if we wanted to. Here's one more example. We have sodium sulfate and calcium phosphate. So we have to write the ions out. Sodium is Na+1. Sulfate, you're going to have to look up on your polyatomic ion sheet. You should recognize that since there's the Na element here, the S element, and the O element, that's probably going to be a ternary ionic compound, so you need to look on your polyatomic ion sheet. By the way, just to review, if something starts with a capital letter, that's a new element. So Na is not 2 elements, N and A, it's 1 element because it's capital N, lowercase a. But then sulfur is a different element and oxygen is a different element, which we know because they're both capitalized. Okay, so sodium sulfate, when we look it up on the polyatomic ion sheet, is SO4 minus 2. If you were in honors chemistry, you'd have to have that memorized. Calcium is Ca plus 2, and phosphate is PO4 minus 3. And we're going to swap them around and put a cation first and an anion that wasn't with it before but is now. So our first cation I'll put in is sodium. So it's going to go with the phosphate ion. And the next one I'm going to put in is calcium, and it's going to go with the sulfate ion. That was a little crazy. And what we need to do here is cancel out the charge. So phosphate's minus 3, sodium's plus 1. So it takes 3 sodiums to cancel out a phosphate. And calcium plus 2 and sulfate minus 2 means it takes 1 of each, a calcium and an SO4, to cancel out. So this is our final reaction. And we're going to stop there for today. And now we're ready to go ahead and try writing the reactions for the ones that I wrote on the board. So let's go ahead and write these out. So we have AlCl3 plus BAS. Al and Cl are 2 separate elements, and Ba and S are 2 separate elements. So this is either double replacement or acid base. And do you see anything that starts with an H or ends with an OH? No, so it's not acid base, so it's double replacement. So our ions are Al is a plus 3, Cl is a minus 1. I have those memorized, you probably don't, so you gotta look them up. So why don't you pause the video here and look up barium and sulfur and see what their charges are. And I'll go ahead and write them in. Okay, so then I'm going to decide which cation I want to write first. It doesn't matter. Let's switch it up and do barium first. Barium, with its plus 2 charge, is going to bond with chlorine with a minus 1 charge. So that's going to be BaCl2. We need 2 chlorines to go with 1 barium to cancel it out. And then aluminum is going to bond with sulfur. Now, this is a little tricky. We've got Al. Can you see this over here? Yeah, plus 3 and sulfur minus 2. You might remember you can do what we call the crisscross method. That looks like that. And you get Al2S3. And that is the correct formula. But the reason that's the correct formula is this. If you have 2 Al plus 3s, that's a total of plus 6 charge. And if you have 3 S minus 2s, that's a total of minus 6 charge. So that does neutralize. So that is the correct formula. So Al2S3 is our answer there. Of course, this one is not balanced. If you wanted to balance it real quick, you could do that. I'm going to not right now. So sodium chloride reacting with oxygen. So this one can't be synthesis or decomposition because they don't have, they might have 2 elements but not a compound and an element. So it could be single replacement. Could it be combustion? No, because this is not a hydrocarbon. Can't be acid-base, can't be double replacement because that's an element by itself. So it must be single replacement. So to find the charges, we say Na is +1. Again, you got to look them up on the periodic table. Those are the charges. So oxygen is going to bond with somebody. Oxygen's -1. It's not going to, -2 I mean. It's not going to bond with -1 chlorine. It's going to bond with sodium. We write the sodium first because it's positive. Na is +1. Oxygen is -2, so you need 2 sodiums to go with it. And then that's going to kick out chlorine by itself, so we're going to write +Cl. Chlorine is going to have a subscript 2 because it's a generene diatomic element. Okay, this one, C4H10 plus O2. This is a hydrocarbon reacting with oxygen. It could only be a combustion reaction. When you have a combustion reaction, you know what the products are, CO2 and H2O. If you want to write it H2O and CO2, that means the same thing. Either order is fine. And the same goes for all the rest of this. We could have done either order. Here we have lithium reacting with oxygen. 2 elements, the only thing they could do is combine together. So lithium and oxygen are going to combine, but you got to think about the charges before you put them together. Lithium is a +1 ion, oxygen is a -2 ion, so this is going to be Li2O, lithium oxide. And it froze. Okay, still going. Maybe it's okay. In this one we have BaO, and BaO is one compound. The only thing it can do is split up. So it's going to split up into Ba, barium, and oxygen. Right? Is that right? Something's wrong with that. What's wrong? Oxygen is diatomic, so that needs to be O2. And last but not least, we have HBr. This is hydrobromic acid and magnesium hydroxide. So that's an acid and a base. And they are going to react to form an ionic compound and water. So I can go ahead and write the water down if I want. And it's really, like we said, it's a type of double replacement reaction. So in this case, what we really did was we took, let's use a different color for this, H plus and Br minus and Mg plus 2. You can look that one up on the periodic table if you'd like. And OH, it's a polyatomic ion, -1. And these two got together to make water. So these two are going to get together now. Of course, we have to write the positive ion first. And it's going to be Mg, that's +2, Br is -1, so we need 2 of these, MgBr2. So, that's our 6 reaction types, 1 example of each. And I hope that helps. Good luck today, and come see me in the WebEx if you have any questions.